Let's learn about exponents. Here, I have written the number 4 with a small 3 above it. When you see something like this, you know that you are working with exponents. But what this is actually saying is that I have the number 4 appearing 3 times and I'm multiplying them by each other. And when I have it written out like this, it's called expanded notation or expanded form. And when it is written with an exponent, it is known as exponential notation or exponential form. To break it down, the number 4 represents our base, and the 3 itself is the actual exponent. Let's dig a bit deeper. Here, we have the base of 4 with a number of different exponents, and it doesn't really matter what the exponent says because it all pretty much means the same thing, that the number 4 is being multiplied repeatedly. In the first one, there was a little 2, which means that there are 2 number 4s being multiplied together. In the second one, there was a 3, so this means that there were 3 being multiplied together, and in the last example, there need to be 4 number 4s being multiplied. So how do we read this? When you have a 4 with a little 2 above it, it is read as 4 squared, and this works for any number with a little 2. The reason we say 4 squared is because when we're working out the area of a square, we would say the one side multiplied by the other side, and in this case I see 4 times 4. Because a square is made up of 2 measurements or 2 dimensions, whenever we see a base with an exponent of a 2, we say that number is being squared. When we have a number with a little 3 above it, and in this case I've got a 4 with a little 3, we read this as 4 cubed. If we were to have a look at a cube, we would see that it has 3 dimensions or 3 measurements. This is why when we see a number with a 3 as an exponent, we call it cubed. Anything higher than the number 3, we would read it as to the power of. So for example, in our last exponent, we have 4 to the power of 4. Pause the video and try the following on your own. Question 1 asks you to expand each of the following. For A, we would read that as 3 to the power of 10. So this means I need to have 10 number 3s written out next to each other and they're all being multiplied together. B, we would read this as 2 cubed. This means that I need to have 3 number 2s being multiplied together. For question C, I would read this as 4 to the power of 5 plus 8 cubed. This means that I would need 5 number 4s and 3 number 8s. The number 4s are being multiplied together and the number 8s are being multiplied together, but our question shows that there is an addition sign between those two bases. So I would need to say 4 times 4 times 4 times 4 times 4 plus 8 times 8 times 8. Question 2 says that we need to write the following in exponential notation. Well, for question A, I can see that my base is 10 and there are 6 10s being multiplied together. Therefore, my answer in exponential form is 10 to the power of 6. For question B, I have a base of 7 and I have 2 7s being multiplied together, so my answer is 7 squared. For question C, I have 2 bases. I have the number 5 and the number 6. There are 3 5s and 2 6s. So in exponential notation, this would read 5 cubed minus 6 squared. Take note of the following. Things like 3 to the power of 10 does not mean 3 times 10 and so on. It means that there are 10 number 3s being multiplied together. Also, when you are asked to write something in the exponential notation, the question is not asking you to solve this. So all you need to do is leave it in exponential form. Now that you know about exponents, you will be expected to solve product of prime factors by leaving numbers in exponential notation. So for this example, we've been given the number 500 that we need to express as a product of its prime factors. So using my ladder method, I'm going to begin with 500 on the top right, and my first prime number is 2. 500 can be divided by 2, which gives me 250. When I divide that by 2, it gives me 125. I can't use 2 anymore, but I can use 5, which is also a prime number. So 125 divided by 5 is 25, 25 divided by 5 is 5, and 5 divided by 5 is 1. This means that 500 is equal to 2 times 2 times 5 times 5 times 5. But if we were asked to leave this in exponential notation, I would have to take note of the fact that I have 2 number 2's, which is 2 squared, and 3 number 5's, which is 5 cubed, and then I would multiply them together. Pause the video and try this next example. Let's see how you did. Express 756 as a product of its prime factors. Leave your answer in exponential notation. So I'm going to begin with 756 in my ladder, and remember to always write out your first 10 prime numbers, especially if you're given a number like this that seems really big. We know that our first prime number is 2, and I can say 756 divided by 2 since it's an even number. When I divide by 2, I get 378, and since that's even, I can divide by 2 again, which leaves me with 189. Now I have an odd number, so I know that the number 2 is not going to work, so I cross it out and move on to my next prime number, which is the number 3. 189 divided by 3 is 63. 63 can be divided by 3, which gives me 21, and 21 can be divided by 3, which gives me 7. 7 divided by 7 is 1. So the answer to 756 as a product of its prime factors is 2 times 2 times 3 times 3 times 3 times 7. But I need to leave this in exponential notation. So I have 2 number 2's, 3 number 3's, and 1 7, and I need to multiply them together. Altogether, I would read this answer as 2 squared times 3 cubed times 7. And this concludes our lesson on exponents.